All right, this is Mrs. Katz, and tonight I'm going to take a few minutes to actually solve all the problems that are on our study guide for the first test in my advanced class for Unit 1. We're just going to go right through them. So what I recommend you do to use this properly is try the problem first, solve it, and then come and watch the video and make sure that you got it right. If you didn't, go back and figure out what you did wrong, and then pause the video and do the same thing with the next question. So here we go. Here's question number 1. What does this mean? It actually means how many 7/8 can go into 4 2/5. How many pieces, how many 7/8 size pieces can fit into 4 2/5? Question number 2 asks us, why is there no such thing as a greatest common multiple? Well, multiples actually go on forever. They are infinite. Okay, infinite. And so if they're infinite, we can never find a biggest one. We can only find a smallest one, which is why we usually find the LCM, the least common multiple. We'll never find a greatest common multiple because multiples go on forever. Now, to find the greatest common factor between 24 and 60, the method that we've been using the most is the sled method. So I'm going to put both numbers on a sled, and I probably should have spaced them out a little bit more. And then I'm going to look for common factor here. I see that 2 goes into each of these, and I know 2 goes into 24 12 times, and 2 goes into 60 30 times. Well, I still have a common factor here that I'm aware of. It looks like 6 could probably go in. 6 goes in 2 times and 5 times. So for GCF, I'm looking for the factors on the left. So in order to find those, they're just the ones that we pulled out, the ones that they shared in common. And for the GCF, we actually multiplied those factors and we get 12. Okay. For number 4, question number 4, we're going to find the least common multiple of 16 and 24. So again, we use the sled method. We're looking for common factors that they share, and they happen to share a 4. So 4 goes into 16 4 times and into 24 6 times. Well, guess what? They still share a factor of 2. So we're going to divide and get those. So 2 goes into 4 twice, and 2 goes into 6 3 times. And GCF is on the left, but LCM is all of them, and it actually makes a little L. And we multiply all of those numbers together. So for the LCM, for this problem, it's going to equal 4 times 2 times 2 times 3. I apologize for the interruption. So 4 times 2 is 8. 8 times 2 is 16. And 16 times 3, I don't know that one off the top of my head. So why not just take it out to the side and do the math? So our LCM is actually 48. Okay. For questions 5, 6, 7, 8, 9, and 10, I'm going to do it on my whiteboard below and then erase it. I would highly recommend that you use a scratch piece of paper. Not all problems fit into a neat little box. So question number 5 is 7,260 divided by 30. So what we're going to do is we ask ourselves the question, how many 30s go into 7? Well, they don't. So we're going to move over to 72. How many 30s go into 72? 2 of those. 2 times 30 is 60. When I subtract, I get 12. Next thing I'm going to do is bring down the 6. Now I've got to make an estimate. And one of the tricks that we talked about was front-end estimation. So like this is 30, but let's think of it as 3 for a minute, and let's think of this as 12. How many 3s go into 12? About 4. So let's try that and see if it at least gets us close. It gets us really close. If we had added an extra 30, we'd be way over 126. So 4 is the answer here, and we multiply to get 120, then we subtract to get 6, and then we bring down. And 30 goes into 60 2 times. We already know that. And 2 times 30 is 60 with a remainder of 0. So this one, the final answer is 242. And notice I boxed in my answer. It's just a great method for you to make sure that I am very clear as to what your answer would be. so that I don't accidentally mark this problem incorrect because I cannot figure out what your answer is. Okay? So we're on to question number 6. I'll do that one here, and then I'll erase them as I go. Question number 6 says 18 and 72 hundredths plus 3 and 7 tenths plus 19. I taught you guys in class it's really great to set up your little template here because those decimals for adding and subtracting, they actually have to line up. So if we do that, we're just going to now build our numbers around those decimals. So the first number was 18 and 72 hundredths. And notice I'm going to make these, big enough that I can see where they're going. And the 19 is all before the decimal. Notice that everything is lined up neatly. And we're going to put some placeholder zeros on this side after the decimal, just so that it's easier for me to figure out, where those numbers go. So 2, when we add, we're going to get 2 here. When we add, we get 14. We carry over the 1. The 9 and the 1 together make a 10. Plus 8 is 18. Plus 3 is 21. The 2 plus the 1 plus the 1 is 4. And that is my final answer. I'm going to box that in. Note, if I'm going too fast for you as you are working, the nice thing about the video is you can always pause and restart anytime you want. You can watch it as many times as you want as well. So let's go on to number 7. 7 is 6.9 times 3.7. And you may ask me, why is that times? I don't see a multiplication symbol here. And what I will say is that anytime you see two numbers in parentheses side by side and there's no operation indicated, we assume multiplication. So this is definitely a multiplication problem. If there was a dot between them, it would be a multiplication problem. Like that. If there was an X between them, it would also be multiplication. Any of those are the exact same problem. Now, we were talking in class about how we kind of eliminate that X an awful lot now at this stage of the game because we're going to use X as a variable very soon, and we don't like it to get confused with the variable. So we're going to start using these symbols a lot more to indicate multiplication. So for multiplication of decimals, actually, don't worry about those decimals at first. You don't have to line them up. I mean, they happen to here, but there's no necessity to do anything other than normal multiplication. So we're just going to multiply. 9 times 7 is 63. Oops. It's after school. I guess I'm getting tired. And 6 times 7 is 42 plus 6 is 48. Then I'm going to place a 0 placeholder as I go to the next row. 3 times 9 is 27. 3 times 6 is 18 plus the 2 is 20. Then I'm going to just add as we would in any other multiplication problem. Now the key here is to figure out, well, where in the world does the decimal go in my answer? And this is how we figure that out. So you're going to look at the problem. Look at the numbers that happen to fall after decimals in your problem. So there's one over here that's after a decimal and one over here. Since there's two of them, we always start our decimal at the end of the number, and we're going to move it the same number of places that we have here. So I'm going to say that one more time, but this will be our final answer. Okay, so let me say that one more time. When you are determining where that decimal should be placed in your answer, you're going to count the decimal places that fall after a decimal in your problem. 9 and 7 both are after decimals, so there's 2 of them. So we take our decimal from the back end of our answer and move it 2 places to the left, and that's how we get our final answer. I'm going to box that in. We're going to move on to question number 8. Question number 8 says 3/7 divided by 1/14. Okay? And to solve this problem, we're going to use that little adage that we talked about in class that you guys remember is keep, change, flip. And we're going to talk about that in math terms. So we are going to keep the first fraction whenever we divide. We're going to change the division into multiplication. I'm going to use a dot to get used to that. And then we are going to flip over the other fraction, making it its reciprocal. Okay? Once we do that, we're going to look top to bottom to see if we have any common factors. So we're going to look at numbers in the top that might share a factor with a number in the bottom. And 14 and 7 share a factor of 7. So we're going to divide by 7 on both of those. When I divide 14 by 7, I get 2. when I divide 7 by 7, I get 1. Since there are no other common factors top to bottom other than the number 1, now we simply multiply across. 3 times 2 is 6, and 1 times 1 is 1. And 6 over 1 is really the same thing as good old 6. Now, in class, I reminded students that it's really great to simplify before we multiply, because if we do that, our answer in the end will already be simplified for us, and we will have done the simplification on much smaller numbers than we would have had we multiplied in the first place. Okay, we're going to move on to question number 9. Question number 9 states 109 minus 2 59/100. Again, just as we did before, I would set up, since this is decimal subtraction, I'm going to set up a structure so I know where those decimals go. And I reminded the students that the decimal actually goes down to the answer. Okay, in division, when we get there, it goes up to go with the answer. In adding and subtracting, it goes down with the answer. So we're just going to place our numbers around these. And 109 is a whole number. All of it goes before the decimal. And 2 59/100 goes here. We're going to put in some 0 placeholders to make sure we have it. And this is a subtraction problem. Now, please don't tell me that this is 9. Okay? It's not 9. I can't take 9 away from nothing. So we've got to get something over here. We're going to reach way over here, turn that into an 8, turn this into a 10. And then we're going to reborrow from the 10 becomes a 9. And that 10 there. We're regrouping our numbers, kind of passing them down the line. So 10 minus 9 is 1, and 9 minus 5 is 4, and 8 minus 2 is 6, and then the 0 and the 1 come down. And here is my final answer. Okay, we're going to move on to question number 10. Question number 10 says 4/5 divided by 1 1/5. Okay, before we can do any division for decimal or for fractions, we need to make sure that they have all been converted to mixed number or to improper fractions. So 4/5 is already has just a numerator and denominator. There are no whole numbers involved. To change this into an improper fraction, first we multiply 5 times 1 because there's 5 pieces in this one whole. Then we add the extra piece we have here, so that makes 6 pieces total. And I keep it over that denominator because I still need 5 pieces to make a whole. Now, notice I kept the division sign here. We haven't done any keeping, changing, flipping, or anything else at the moment. All we did was convert this fraction into an improper fraction. Now, we keep, we change, and I'll put an X so that we can see that it's the same thing, and we flip over to the reciprocal. We make that fraction its reciprocal. And then we do the division. Now, again, I always say, simplify before you multiply. So the two 5s can simplify. They both share a common factor of 5, making them each equal to 1 when we divide. The 4 and the 6 share a common factor of 2. So when I divide, I get a 2 and a 3. Now in the multiplication of fractions, we simply multiply across. 2 times 1 equals 2, and 1 times 3 equals 3. We knew we were ready to do that because there were no other common factors top to bottom other than the number 1. All right, we're going to go on to question number 11. So question number 11 says that Aletta buys bird food every 9 days and hamster food every 12 days. If she buys both kinds of pet food today, in how many days will she next have to buy the pet food? So we talked a lot about some of those keywords that you might see in a word problem that will help you determine if you're using GCF, LCM, etc. Let's take a look here. It doesn't have any greatest or least or any of those kinds of words in here, so that's not helping us. But we want them both to buy something or to have something at the same time. So when you see the word both, oftentimes we're trying to get both of them to the same place. And look, if she buys bird food every 9 days, she's going to buy bird food on day 9, on day 18, on day 27, etc. And if she buys hamster food every 12 days, she's going to buy it on the 12th day, the 24th day, the 36th day, etc. So once you see that you're actually writing out the multiples of those numbers, we probably know we're looking for LCM. Now, we've used the sled method a bunch, but since I'm already on a roll, let's use the list method for this one. Let's keep going until we can find something that matches. So after 27 comes 36. And we happen to note that that's the same multiple in both cases. So on the 36th day, on day 36, she will buy both. All right, on question number 12, Daniel threw the football 15 1/3 yards over 5 plays. We want to know how many yards did he average per play. Now, we didn't really talk about the word average, so this problem might be a little bit perplexing, but average just means divide it up and tell me how much per day to get to that. So really, this problem boils down to 15 1/3 divided by 5. Okay. Again, I highly recommend that you use scratch paper, not scratch paper, but additional paper to do all these problems. And please label them and number them accordingly so that I know where to find the work. But I'm going to try to squeeze that in over here so you can kind of see it. Actually, I'm going to put it up here. So it was 15 1/3 divided by 5. Now, before we can divide these fractions, we need to make sure that they are fractions that have only numerators, denominators. They can't have any whole numbers at all. So for this one, we're going to multiply. 15 times 3 is 45, plus the 1, so that's 46 thirds. And when you have a whole number, you can just place it over 1. It means the exact same thing. Notice that I still didn't keep or flip or change or anything. This is still a division problem. We just converted it over so we can work with it. Then we're going to keep, we're going to change, and we're going to flip. Do you see any common factors top to bottom? Well, when you add 4 and 6, you get the number 10, and 10 is not divisible by 3. So 3 and 46 are not compatible. 46 doesn't end in a 5 or a 0, so 46 and 5 are not compatible. So now we just simply multiply across. And that is a perfectly acceptable answer. It's simplified. It's great. If you want to turn it into an improper or a mixed number, 15 goes into 46 3 times with 1 left over when you needed 15 to make another whole. So either of those answers is acceptable. All right, let's move on to question number 13. So hamburgers are sold in packages of 6 and buns in packages of 8. What is the best, the least, so this is the key word here, the least number of packages of each that can be bought to make hamburger sandwiches? A sandwich has 1 bun and 1 burger. We don't want any buns or burgers left over. So we're looking for least. That's usually signifying an LCM. So we're going to use 6 and 8, and their shared factor is 2. It goes into 6 3 times. It goes into 8 4 times. And that's all the math I can do on that because 3, 4 do not share any common factor other than 1. So LCM is all of them. We're going to take all those factors and multiply them. It equals 2 times 3 times 4. That's 24. Now, that answer is not the answer they were looking for. They want to know what is the least number of packages of each. Okay? Now, we know we're going to make 24 total sandwiches, which means I need 24 hamburgers and I need 24 buns. Well, if the hamburgers are sold in packages of 6 and the buns are sold in packages of 8, and I need a total of 24 of each, 6 times what gets me 24? Well, it turns out I'm going to need 4 packs of hamburgers because 4 times 6 will get me the 24 I need to make my sandwiches. And I'm going to need 3 packs of buns because 8 times 3 is going to get me the 24 buns that I need. Question number 14 says, ticket sales for a concert totaled $120,400. Tickets for the concert cost $25 each. We want to know how many tickets were sold. This is a simple division problem. I'm going to take the total amount of money that we made and divide it by the $25 per ticket to find out how many tickets sold. 25 does not go into 1, it does not go into 12, but it does go into 120. And it actually goes 4 times because 4 times 25, that's a money number. You should be thinking of quarters, makes 100. When we subtract, we get 20. We bring down the 4. 25 goes into 204 actually 8 times because there's 4 25s in every 100, and there's 200 here. So that's going to make 200. And then I get this, and we bring down the 0. And 25 goes into 40 one time. When I subtract, I get 15. And 25 goes into 150 6 times. So that is 150 and leaves me with the remainder of 0. So 4,816 tickets were sold. Okay. Question number 15. We actually didn't do much of this in class, but it could be a little intuitive, and it's really hard to see on this paper because it's black. But there are actually 4 sections here. 1, 2, 3, 4 that are shaded. I don't know if you can see that real well. Let me put a lighter color up here. 1, 2, 3, 4. And there are 2 that are blank. Okay, so there's 6 segments altogether. So 4/6 is this fraction. There are 4 parts shaded out of the 6 that were there. And for this one, it actually has 4 parts shaded out of 1, 2, 3, 4, 5, 6, 7, 8, plus the 4, that's 12. So this is going to be divided by 4/12. And honestly, how many of these 4/12 will fit into this diagram? There'll be 2 of them. So that should equal 2. And you can see that if you use your keep, change, flip method. We're going to keep the first one, change to multiplication, flip the second one to its reciprocal, and we're going to simplify. 4 divided by 4 is 1, and same thing down here. 6 and 12 share a common factor of 6, leaving me with 1 and 2. When I multiply, I get 2 over 1, which equals 2. All right, question 16. Erin has $18 to buy school supplies, and she buys 5 folders that are 55 cents each, including tax. She buys a binder that costs that. She spends the remaining money buying pencils that are 25 cents each. If she has no money left over, how many pencils did she buy? So I'm going to actually take this up here a little bit so I can work below. Oops, maybe not. Okay. So we're going to just fold this up so it's easier to stay where it's supposed to. So question number 16, she's got $18. So let's figure out what she's spent so far. Well, we know that she's bought 5 folders that are 55 cents. When I multiply, I get that. And there are 2 places after decimals. So I'm going to move the decimal this place. So she spent $2.75. Oh, sorry, guys. It's a little dark. Hold on. On folders. Okay. Then we know that she buys 1 binder that costs $12.25. So we're going to take that $12.25. We're going to add it to the $2.75 that she spent on folders. And when I add, remember, we got to line those decimals up. Okay. Add them. And I get $15. She had $18 to spend altogether. So if I take the $18 and I subtract the $15, I'm left with $3. And we want to know how many 25 cents are in $3. Well, there's 4 quarters in $1. 4 times 3 is 12. So she can buy 12 pencils. Alrighty. Question number 17. So on question number 17, it says we've got a shelf that it's 4 3/5 inches long, and we have CDs that are 1/3 inch long. How many CDs can be placed on the shelf? Now, if I asked this question a little differently, I think you guys could handle it. If I said I have a shelf that's 4 inches wide, so 4 inches wide, and I have CDs that are 1 inch wide, how many CDs could I fit on the shelf? Well, I think most of you guys would tell me 4, no problem, because 4 divided by 1 is 4. As soon as I introduce a fraction, all of a sudden you guys don't know what you're doing. But it's the same problem. 4 3/5 needs to be divided by how many 1/3 can go in there. So before I can do the division, I've got to change everything so we have no whole numbers. So 5 times 4 is 20, plus 3 is 23/5. And I'm still dividing because I haven't changed anything yet. So I'm going to move up here so you can see it all. So 23/5 is keep. change, and we're going to flip to the reciprocal here. No common factors exist top to bottom, so we're going to just multiply across. And 23 times 3 is 69, and fifth. Now, here's the deal. 5 doesn't go into 69 evenly, but we're going to see how far it can take us. So we're going to take 69, divide it by 5. We're going to get 1 and 19, and 5 goes into 19 3 times. That's 15. And there's 4 left over. So here's the deal. What this means is I can fit 13 whole CDs on there. And we're going to have part of another CD left over. So we can fit 13 CDs. This is a case where we would actually round down because I can't put part of a CD on a shelf. I want to know how many CDs I can fit. I can fit 13 CDs. All right, here comes question number 18. Question number 18 says, using the information from problem 17, how did you solve the problem and compute the answer? Well, we just talked about it. We just talked about the fact that the answer to number 18 I would write as something along the lines of, how did you solve it? I used long division, and I rounded down. Because I can't put what? I can't put a part of a CD on a shelf. And that is what your answer should look like for that question. Okay. Question number 19 says that a roller coaster train holds 40 passengers. If there are 315 people in line to ride, we want to know how many times the train will have to go for everyone to be able to ride. Everyone is a key word here. We're not leaving anybody out. So even if we have remainders left over, they need to ride too. So we're going to take that 315 people that are in line, and every time a train goes down, 40 people get to go. We want to know how many times we can do that. So 40 doesn't go into 3, and it doesn't go into 31. And 4 goes into 31 about 7 times. So we're going to do this 40 times 7, 280. If I add another 40, I'm going to get up to 320. That's too much. So 7 times, leaving me at 280. If I subtract, I get 5. Remember, I've got to regroup here. I'll have 35 left over. Okay, so let's talk about this. This is people on a full train. This is the number of full trains. This is the number of people who still have to ride. Okay, the leftover, the remainder here, are the people that didn't make it onto a full train. So we still have to send those 35 people down the ride. They're just not going to fill up a train. So in the end, the final answer is going to be 8. We will need to send 8 trains down the chute to make sure that all the people get to go. 7 trains will be full, and the last one will be missing 5 people. But we need to make sure these guys get to ride too. All right. And question number 20. What topic do you need to study the most? Take a look at those. Your MSG is chock full of information, notes, practice problems, and all of that. We've done tons of work this unit. So if you find that you're really struggling on any one of those topics, please make sure you look back at your MSG. You look back at the practice videos and instructional videos that are on our blog, and you ask me if you need it. I hope this helps, and I hope you guys study hard. I will see you tomorrow.